next lesson is looking at common factors with polynomials again, but furthering that to look at grouping. We're going to start off with a couple examples of finding the greatest common factor again, and then we're going to look at how we group polynomials. So in this first example, we have two terms, and you'll notice that in each of those terms, x plus 1 is a common factor. So here we're going to look at this. This is our first term in our polynomial. This is our second term in our polynomial. And you'll notice that x plus 1 is common to both of those terms, and it happens to be the greatest common factor of both terms. So let's take a look what happens when we factor this out of this polynomial. So essentially we're dividing each of these terms by x plus 1. I'm going to write x plus 1 here, and then another bracket. Now when we divide x plus 1 out of this first term, we're left with just 2x. And when we divide x plus 1 out of this second term, we have 5. And so our factorization of this polynomial becomes x plus 1, which was the common term, and 2x plus 5. And if we go back to our distribution rule, we'll see that if we take this first term and multiply by the first term in the second binomial, we get 2x times x plus 1. And again, if we take that first term and we multiply here, that gives us plus 5 times x plus 1, which gives us the original polynomial back. So using distribution, we can get our original polynomial back as we did in the previous lesson. Let's look at one more example of that, and then we're going to look at grouping. In this example here, we have 4x times x plus 5 minus 3 times x plus 5. So you'll notice that x plus 5 is the common term between these two terms, common factor. So again, this is our first term, this is our second term, and x plus 5 is common to both. So if we factor the x plus 5 out, now we want to look at what we have to multiply this by in order to get this original polynomial again. So if we divide this first term by x plus 5, that leaves 4x. And if we divide the second term by x plus 5, we're left with minus 3. And again, if we wanted to double check our answer, we could distribute by taking this first term, multiplying here by our first term in the second binomial, 4x times x plus 5, and then taking x plus 5 again and multiplying by negative 3. And you'll see we get the original polynomial back. Now these are set up very nicely for you with common terms, but that is not always the case. Let's look at a couple examples. And this is called factoring by grouping here. So you'll notice in this first example, we have x squared plus 2x plus x plus 2. And you'll notice in these first two terms here, that these two terms have a common factor of x. And if I were to factor the x out of those two terms, we would be left with x times x plus 2. Now we still have these two terms here, plus x plus 2. But you'll notice now if I put brackets around here, I haven't changed the value of the equation, the expression, sorry. But I have two common terms. I have a common term x plus 2 here, and I have a common factor, x plus 2 here. And you'll notice that this is our first term again, and this is our second term. So now if we divide both terms by x plus 2, in this first term, dividing x times x plus 2 by x plus 2, that leaves us with x. What happens in this second term? I'm just going to write this out down here. If I have x plus 2 and I divide that by x plus 2, that leaves us with just 1. Because x plus 2 divided by x plus 2 is just 1. So here, if I factor this x plus 2 out, I'm left with 1. Now, if we distribute again and double check that this is the correct factorization of this, I can take the x plus 2 and multiply by x to give us x times x plus 2, and then take that and multiply by 1 times x plus 2. Now in our original, we distributed this as well, and that gave us x squared plus 2x, and then plus x plus 2, which was our original polynomial. Okay, let's look at another example of that. In this example here, if we look at these two terms first, these two terms have a common factor of y squared. So let's go ahead and factor out the y squared out of these two terms, and that leaves us with y minus 14. Now you'll notice here, we also have a y minus 14. I'm just going to write that down here. Now, if we put brackets around that, we haven't changed the value of our expression, but you'll notice that that sets us up so that we have a y minus 14 term that is common to both of those terms. And again, we can factor that y minus 14 out, and that would give us y minus 14. Now, if I divide this first term by y minus 14, we're left with y squared. And if we divide this term by y minus 14, we're left with plus 1. Let's look at another example that has a negative that we have to deal with. In this example here, you'll notice that in these first two terms, we have a z in common. And we can rewrite those first two terms as z times z minus 4. Now, then we have this minus 10z plus 40. But you'll notice that these two terms, I'm just going to rewrite this down here. These two terms have 10 in common. But here we have a negative. So if I factor this negative 10 out of these two values, these two terms, in this first term I'm left with z. In this second term, I can't have a plus 4 because if we were to distribute, it would end up being negative. So we have to change the sign here to negative 4 because we're factoring the negative 10 out of that, and that leaves us with negative 4. Now we have set ourselves up with z minus 4 in common with both terms, so we can factor out z minus 4. And when we divide both terms by z minus 4, we're left here with z and here with minus 10. Okay, let's do one more example. In this last example, if we look at the first two terms here, we have y in common. And if we factor y out, that leaves us with y plus 3. And in these two terms, we have negative 8 in common. So let's factor out negative 8, and again that leaves us with y plus 3. You'll notice if I factor negative out here, or divide negative 24 by negative 8, that leaves us with positive 3. So here we have y plus 3 that is common to both of these terms. And I can factor that out, y plus 3. So that leaves us here with y, and then in this term, minus 8.